In our first example here, we're going to verify that a basis is orthogonal and find an orthonormal basis from these vectors. It's really not super hard, but it's definitely worth going over here. And we only have to have that the dot product to be 0 to show that, in fact, these vectors are orthogonal. We just have to make sure that we do all of them and every combination. And just using the notation here, obviously it's just a dot product. We don't have to get too carried away with notation. But if we're using the matrix version of this, it's rows times columns. So we have to make sure that we use it as a U1 transpose multiplied times U2. That's essentially our dot product here. But we know how to do this. You're just going to multiply corresponding elements and then add the result, just like any other dot product. So we would end up with something that looks like -1 plus 0 plus 1, and clearly that's 0. So we verified that U1 and U2 are orthogonal to each other. So let's verify that U1 and U3 are orthogonal. And again, just forming that dot product, we would have 0 plus 0 plus 0. So that's obviously 0. So we can see that U1 and U3 are orthogonal to each other. And now it's just verifying that U2 and U3 are orthogonal to each other as well. So now we'll take U2 and U3 and dot those. And again, forming that dot product there, you would end up with a similar result as the previous one, 0 plus 0 plus 0. So we get that the dot products of all these combinations of vectors then is 0. So we have an orthogonal basis, pretty quick to check. If we want to make it an orthonormal basis, we're just going to have to divide each vector by its magnitude, and that will do it. So then U1 will just be equal to 1 over root 2, 0, and 1 over root 2. U2 is going to look like -1 over root 2, 0, and 1 over root 2. And then U3 already has a magnitude of 1. So it'll stay the same, 0, 1, 0. So having an orthonormal basis is sometimes useful. A lot of times just the orthogonal basis is enough, and you'll notice that the numbers within the orthogonal basis are generally a little bit cleaner to work with. But if we need that orthonormal basis, then we can find that pretty quickly as well.